In this video, you will learn that in two quite different ways, the burning of fossil fuels can cause our rain to become acidified. Sulfuric acid arises from the burning of coal and oil, mainly in power stations, whereas nitric acid arises from the exhaust pipes of our motor vehicles. You will also see some of the effects acid rain has on our environment. Firstly, it's important to understand that rain is naturally slightly acidic. Whilst falling to the ground, the rain dissolves carbon dioxide from the atmosphere to form carbonic acid, a weak acid giving natural rain a pH of 6. It's when we burn fossil fuels that much stronger acids get into our rain, to form acid rain with a pH as low as 3. When the pH changes from 6 to 3, what do you think the acidity increases by? 2 times? 3 times? 10 times? 1,000 times? Pause and think. Remember that each change of 1 in pH is a tenfold change in acidity, so changing from 6 to 3 is 10 times 10 times 10, or 1,000 times more acidic. We'll consider sulfuric acid first. Plants need a little sulfur to grow. They obtain it from sulfates, for example potassium sulfate, found naturally in the soil. The sulfates are taken up by the plant's roots, and sulfur atoms become bonded to carbon atoms in the leaves' proteins. When plants die, and eventually form coal and oil over millions of years, these sulfur atoms remain bonded to the carbon atoms. The sulfur content of coal and oil is usually between 1 and 4% by weight. What do you think is produced when fossil fuels containing sulfur are burnt? Pause the video whilst you think. When the coal is burnt, the sulfur and the carbon atoms join with oxygen from the air and are released into the atmosphere as carbon dioxide and sulfur dioxide. In the presence of sunlight, a photochemical reaction will take place, where sulfur dioxide reacts with more oxygen to form sulfur trioxide. This dissolves in the rainwater, forming sulfuric acid. Let's now consider how nitric acid gets into the rain. In the high temperature conditions in the cylinders of our motor vehicles, a small amount of nitrogen and oxygen from the air can react. Remember that air taken in to combust the fuel is nearly 80% nitrogen. So exhaust gases from vehicles contain small but significant amounts of nitrogen oxides. Once the oxides of nitrogen are in the air, they react with more oxygen, just like we saw with sulfur dioxide, and dissolve in the rainwater to form nitric acid. If the rain falls on limestone soils which are alkaline, the acidity may be neutralized. However, if the rain lands on neutral or acid soils or on vegetation, then it can cause damage. So why is this acidity harmful to living things? Well, living things don't grow well in acid conditions, and it's easy to demonstrate this. Soak a slice of bread in vinegar and another in pure water, leave them open for a little while, and then leave them covered for a week. You will find that the bread soaked in vinegar has not gone mouldy, whereas the other bread has. In fact, we use vinegar to preserve food in a process called pickling. This is the case because certain enzymes which are vital for growth are unable to function in acid conditions. The other main problem is in the soil. Whilst naturally occurring toxic metals such as aluminium are insoluble and therefore fairly harmless in neutral soil, they become soluble in acidic soil. They then get taken up by living things and take the place of essential metals such as zinc and iron. To add to this, the hydrogen ions in the acid rain will replace essential metal ions such as potassium, magnesium and calcium, which are normally held in the clay soil, causing these essential metals to be washed deep into the subsoil away from the roots of plants. So to summarize, normal rain is slightly acidic due to the dissolved carbon dioxide, but acid rain contains sulfuric and nitric acid, making the rain 1,000 times more acidic and dangerous for many living things. Sulfuric acid arises from the burning of fossil fuels containing sulfur, Nitric acid arises from the combustion of atmospheric oxygen and nitrogen in the high temperature conditions in the cylinders of petrol and diesel engines.
No. Huh?